Hey everyone. I couldn't really find a good time for everybody to be able to come and do a final exam review, so I'm just going to put together this just without anybody here, and I'll just go through some problems and stuff, and hopefully it'll be helpful for you. I'll also post or send in a message the the practice exam that I am going to be working through, as well as the key, so that you can look at that to see if that can be helpful for you as well. But before we get into that, I just wanted to make sure that everybody knew and remembered just about a few things here that I posted in the last announcement, right? So the final exam needs to be taken in the testing center either on December 11th, 12th, or 13th, and make sure you get it scheduled as soon as possible, because there's a lot of students that are going to be taking finals in the testing center this coming week, and so that way you'll get the best chance of a time that works best for you, right? And then also I just wanted to make sure that you saw the things that I put on here about getting ready for the final exam. So if you look at the modules in the course final exam module, there's this final exam details and preparation, and so it goes through, and so we have all these objective reviews that you can go through and the keys, and those are a great way to study for the exam. It's the most comprehensive way to do so. They also have some flashcards on here that you can go through just to kind of test yourself on different formulas and stuff, like slope formula, if you're trying to make sure you remember what it is, right? Then you can think it to yourself and then see if you're right, and it gives it to you there. So these flashcards can be a really good way of studying for some of the formulas and stuff that you need to know. Okay. And then also it gives you some exam details on here. You have 2 hours to take it. It's going to be 30 questions long. You can use a scientific calculator, but there's no notes allowed. That's kind of the general thing, but if you want to know more specifics about it, make sure that you read and ask, look at these frequently asked questions for more information there. Okay, but then in addition to the things that are in that final exam module, a couple of things that I gave you as advice to do is go through all of the 3 past final exams that we have taken, and make sure you understand the concepts on those. If it's on one of the midterm tests, it definitely could be on the final exam as well. Okay, I also put in here some questions that you can work through. It's something that I did with my in-person class, and so I just posted it here, and there's also solutions. So this is a really good review of different types of questions that have shown up on the Math 990 final exams in the past, and so they could be things that might show up again. Also, there was a review this morning at 10 a.m. and then there's going to be one tomorrow morning at 10:30 a.m. Now these are in-person ones at the STEM Center, and I'm looking into seeing if there's other final exam reviews that other instructors are holding via Zoom. So those of you that want to be able to try and attend something that way, hopefully I can find something, and if I get that information, I will send that on to you. Okay, and then make sure that you take advantage of these extra credit opportunities. So there's 2 practice final exams there in that final exam module. If you'll notice here, let me go back so you can see. So you'll see there's practice final exam 1, practice final exam 2, and so those are some extra credits that you can do. They're set up kind of like your homework problems, so you'll know immediately, you'll get immediate feedback on it to know if you have it right or not, and then be able to see what the correct answer should have been and work through it that way. So those are best to work on after you've went through other things like those course objective reviews, or going through that stuff that I gave you in in here, right? So these little end of the semester reviews that I did, as well as, going through the one that I'm going to do with you today. And after you've kind of done those things and went through the old tests and stuff, then it would be a good idea to take it. And so take it like they're actual final exams to give yourself some practice on, especially the timing. So you'll have 2 hours to complete it. So give yourself 2 hours to take these, and make sure you only are using your scientific calculator and nothing else, just so you can see what do you actually know, what do you still need more help with. Okay, and then the last thing that you can do for extra credit is the course evaluation, and so make sure you do that and then get that submitted for some other extra points. Okay, all right, so let's go ahead and start. I'm going to start working through some of these problems, and I might do so kind of quickly because you can pause it and rewind it if you need to look back over it again. Okay, so on this first one, definitely there's something, we've done these kind of problems a lot in the past where you just need to be able to solve these equations. So let's first distribute that through. So I get 8x minus 8 equals 5. Now notice on this one it's a negative 3 that we're distributing through both. So I've got minus 3x, but then plus 9. And then I need to get my like terms together. So I've got 8x minus 8. And on this side I can combine my 5 and my 9 together. So I'll have 14 minus 3x. And now let's get the x's on one side and whole numbers on the other side. So I'm going to add my 3x to the left, and I'm going to add the 8 over on the right. And when I do that, I end up with 11x equals 22. And then I can divide by 11. So x equals 2 is my answer on that. Okay, and notice that the next part, there were some people on the exam that we did that had this on it were kind of confused by this, but this is just checking your answers to make sure that you did it correctly, so you're getting some points for that. So you take this answer that you came up with and you're just going to plug it back into that original equation everywhere you see an x. Right? So that's what I'm going to do down here. So I'll have 8 parenthesis, in place of the x I'll put 2, 2 minus 1 equals 5 minus 3 parenthesis, 2 minus 3. And so then I need to do what's in parentheses first. So 2 minus 1 is just 1. And then here I need to still do what's in parentheses first. Right? So 2 minus 3 is negative 1. And now I need to make sure that I do the multiplication. So these two things, don't add the 5 and the negative 3 together. I'm not subtracting that first. I got to do my multiplication first. So on this side I get 8 equals 5 plus 3, and 5 plus 3 is 8. So 8 equals 8. So that means that is indeed x equals 2 is the correct answer. Okay, so it's just asking you to check there. That's all I want you to do. All right, on this next one, we're solving an equation again, but it has fractions in it. And so when we're solving something with fractions, we need to remember that we've got to find the LCD. And so to find the LCD on this, remember you're looking for the multiples of each of those numbers. So 2 is over 1, all right? So if I list the multiples of 6, so if I count by 6, 6, 12, 18, and so on, list multiples of 3, 3, 6, 9, 12, 15, and so on, right? And I can see that 6 is the first multiple that they have in common, so that is what my LCD would be. Now if you chose 12 or if you chose 18, those are common denominators and they will work on this. They just will require more simplifying in the end. Okay, but let's take 6 and I'm going to multiply each part by 6, right? So I've got to do that here. So I'm going to put it as 6 over 1, and then I need to multiply this part by 6, and then also this last one by 6. So make sure you're doing each part by it. A lot of times this 2, that whole number, gets forgotten, that you've got to multiply the 6 by it as well. All right, so when I do that here, I can see that my 6's divide out, all right, leaving me with negative 5x. And then here, 2 times 6 is 12, so equals 12. And then on this one, 3 can divide into 6. 2 times 4 is 8. And I can't forget about that x as well. All right, so I just killed off the denominators, and so I don't need to work with the denominators anymore, and it makes it much easier to solve. So I'm going to subtract the 8x over so I can get those x's together, and I get negative 13x equals 12, and then my last step is to divide by negative 13. So x equals negative 12/13 would be the answer. And anytime you have a question that says solve on this test, you can always check your answers, kind of like we did on that first problem. So definitely, if you have time at the end, I would highly suggest that you do that, just to make sure you didn't make some kind of an arithmetic mistake, and then you could go back and fix that if it doesn't check out. Okay, for number 3, this one we have a rectangular room, so I'm going to start off by just drawing a picture, right, of a rectangle. And because if I'm trying to imagine something in my head, I might as well just draw it out, right? So a rectangular room is 3 times as long as it is wide. So it's not telling me how wide it is, so I'm going to call that W. And then I can see there's a relationship to the length of it, right? It's 3 times whatever the width is. So that would be 3W. All right, then the next part said its perimeter. Now notice, make sure you take notice on the exam. Is it asking for perimeter or is it asking for area? Because we would be using kind of a different formula on that, right? So perimeter is 48. So I'm just going to put inside here P equals 48 so I remember. So just a couple of things to keep in mind, right? So perimeter, you add all sides is how you need to do that, where area of a rectangle is the length times the width. So in this one we want to add all sides together. So that side would also be W because it's the same as the one straight across from it, and this is 3W. So if I add all those together, I get 3W plus W plus 3W plus W equals 48. Okay, and that's really what is going to go right here in this blank. It says write an algebraic equation used to solve this, and then we'll solve it. All right, so if we go ahead and solve this, if I combine all of those W's together, I get 8W equals 48, and then I need to divide by 8, so W equals 6. Now make sure you remember your labels on this. You'll notice that sometimes, you know, like you're going to miss points on that if you don't, so make sure you're using those. So this said that it was in meters, so I've got here 48 meters, so I'm going to say this is 6 meters is my width. Make sure you put it in the correct blank there, so that's here, 6 meters. And then my length is going to be 3 times 6, right? So I know my width was 6, so put 3 in place of that, or sorry, 6 in place of it. 3 times 6 is 18. So 18 meters is the length. Okay, and again, you could add all of those sides together, right? 18 plus 6 plus 18 plus 6, and those better add up to be 48. So that's a way that you can check that one. Okay, on this next one, this is direct variation. So on the last exam, it seemed like a lot of people were forgetting this formula, so make sure you remember the formulas for it. So if it varies directly, that's y equals k times x, and if it's inverse variation, then it's y equals k divided by x. All right, because the inverse of multiplication is division, so that's why those are kind of how those are related together there. All right, so let's look at this. The weekly pay that Lexi receives varies directly with the number of hours she works. Okay, so remember we said, okay, we're going to be using this one, but I'm going to change my variables to kind of go with what we have here, right? So weekly pay, so that's W, right? I'm going to say weekly pay is W, that Lexi receives varies directly with the number of hours she works. So, and I'm going to call the number of hours H. So I've got K times H. And I just do this just to make sure that I'm putting the numbers in the correct place. Right? So now I can put these in. If she works 27 hours, so that will go here in place of the H, she makes $527.85. All right, so I get that equals 27K. All right, and then to solve for K, we just need to divide both sides by 27. And then when you do that, right, you can do that just on your calculator, and that's going to give us $19, and 55 cents, right? Because it is talking about money. This is basically her hourly wage, right, is what she's making there. And then it says, okay, now what if she worked 25 hours? So we know she makes $19.55 an hour. So if she worked 25 hours, then her weekly pay would be 19.55 times the 25. Okay, and again, if you put that into your calculator, multiply those together, you'll get $488.75. Okay. And so those are the two answers that we need there. So we need to know K for part A, and then what, the weekly pay is after that. All right, and if it's inverse variation, then remember you'll be using this formula instead, but pretty much works the same way. All right, let's look now at number 5. All right, so this you've seen on an exam before, and so it could be a very good chance that it shows up on the final, right? So a student has scores of 81, 75, and 63 on his first three tests. He needs an average of at least 70 to earn a C grade in the class. What is the minimum score that he needs on the fourth to ensure a C? So let's think about, how do we find an average? Well, we add all the numbers together and then divide by how many there are. Well, we know that the scores on the first 3 tests, but we don't know how much he's going to get on the fourth test, so that's going to be our variable. That's what I don't know. So if I take 81 plus 75 plus 63 plus X, because I don't know what he's going to get on that fourth exam, but I know there's going to be 4 exams, so I would be dividing that by 4. Right, and that would give me the average. Well, he wants to have at least 70, so that means I need to put this as greater than or equal to 70. Right, so he doesn't want to get below a 70 in the class, because that would make sure that he didn't have a C, which is what he wants. So that's what we're going to put there. Okay, and then so we'll write that inequality in there, and then go ahead and solve it. So on this, you can see I need to get rid of that dividing by 4. So I'll start by multiplying both sides by 4 to get rid of that. All right, so those are gone. And then I'm left with, let's add that 81, 75, and 63 together. When I add those 3 together, I get 199. Plus X, whatever he gets on that last test score, needs to be greater than or equal to, well, 70 times 4 is going to be 280. And then to get X by itself, I just need to subtract that 199 over. Okay. And when you do that, we say X has to be greater than or equal to 81. All right, so he can get an 81 on the exam. But he could get more than that too and still stay above a C in the class. So the minimum score he could get would be an 81. Okay. All right, we'll keep going here. All right, so solve the compound inequality. Make sure you notice on this one, it's an and statement. All right, and so remember when we're dealing with and, that means that we want the intersection, and so we want the places where there's overlap, right, where they overlap. Okay, so let's solve each of these separately, and then we'll come back to that little word and, what we do there. All right, so let's start by adding 1 over to both sides on this one. So negative 3x is less than or equal to negative 6. Divide by negative 3, and if I divide by a negative, I need to remember to flip my inequality sign the other way. I'm going to change that color of it just to make sure. You see that I flipped that, all right, inequality sign the other way, and negative 6 divided by negative 3 is positive 2. Okay, so there's one of my solutions, and then on the other one I just need to subtract 2 to get x by itself, so x is greater than 3. Now I need to put it on my number line here, so here's 2 and here's 3, right? Make sure that it's going from smallest to biggest. So I know that x is greater than or equal to 2. So at 2, I've got a closed circle, and then everything greater than it is everything to the right. And then on the next one, x is greater than 3, so that's an open circle here at 3, and then everything to the right. Okay, but this and statement, remember, is telling us that we want just where it's overlapping. Well, the parts that it's overlapping is here from 3 and on, right? There's no overlap between 2 and 3, so we don't want the stuff there, just 3 and bigger. And so when we write that in interval notation, well, 3 has an open circle on it, so that means it's a parenthesis, 3, and then out to infinity. So that would be your answer there. Okay. So, and if it was an or statement, then we would want everything, right? Everywhere the graphs appear. So that would be from 2 to infinity if it was an or statement. Okay, so watch those little words and an or to make sure you know what you need to do there. All right, so here's a tripartite, and so the easiest way to solve these is to get x by itself in the middle. So to do that, I'm going to start by looking here and saying, okay, I want to get x by itself in the middle, so I'm going to subtract 2, but if I subtract 2 here, I've got to subtract 2 in all the parts, so I'm going to subtract 2 there as well as there, right? So 3 different parts I'm subtracting 2. When I do that in the middle, that's gone. On the left side, I get 6 is less than or equal to 3x, which is less than 11 minus 2 is 9. And then right now, to get x by itself, it's multiplied by 3, so I need to divide each part by 3. So that will give me 2 is less than or equal to x, which is less than 3. So if I read this properly, all right, what it really is saying is x is between, all right, between 2 and 3, but it's including 2 because it has that equal to part on next to the 2. So to write this in interval notation, all right, I would say, okay, all the stuff between 2 and 3, so bracket 2 to 3 and then parenthesis because it doesn't have the equal to part on it. All right, so all of the stuff between 2 and 3 would be my answer. Okay. All right, now on absolute value equations and inequalities, remember with absolute value, we have to start by making sure the absolute value part is by itself, which it is here, and then you're going to write 2 statements for it. So the first one is just the same as it's here, just without the absolute value bar. All right, so I just take those off. And then the other ones, we're going to keep that 2x minus 6 the same. But now I need to change that greater than symbol to less than. So I'm flipping the inequality, and I've got to change the sign of that to its opposite. So I'll make that -4. So now this is less than -4. Okay, and then we have to look here to figure out whether it's an and or statement, meaning do we want just where they're overlapping or do we want everywhere those graphs show up? Well, this is a gray-tor, right? So it's just a play on words here to help us remember gray-tor. So it's an or statement, which means we want everything. That's the union. So that means everywhere the graph shows up. All right, so let's keep solving these and I'll show you what I mean by that. So let's add our 6 over. So we get 2x is greater than 10, divide by 2, x is greater than 5. And then on this one, we add the 6 over. We get 2x is less than 2, and we'll divide by 2, so x is less than 1. All right, so let's graph both of these and see. So I've got -1 is somewhere down here, 5 is going to be somewhere to the right of it. All right, so x is greater than 5 means that we're going to have an open circle at 5 and everything bigger than it. And then the other one, x is less than -1. So again, an open circle here, right? But this time everything to the left. And so since this is an or statement, all right, we want everywhere they show up. So all the stuff less than -1, all the stuff bigger than 5. And so if we write that in interval notation, we're going to read it from left to right, right? So this is going clear out to -infinity. So parenthesis, -infinity to -1. It doesn't include 1 because it's an open circle there. And then union, parenthesis 5, clear out to +infinity. And that would be your answer for that interval notation. Okay, be careful with interval notation and make sure you're always writing it smallest to biggest. All right, if you write, like if you were to write this part as -1 to -infinity, that would get marked wrong because you're not reading it from smallest to biggest. Okay, and that doesn't make sense in interval notation unless it's written that way. Okay, number 9. Here we're trying to find the domain and range and then whether it's a function or not. So recall that domain is our x values and our range is our y values. And so we're really just looking at these ordered pairs and finding our x and our y's. Well, let's list all of our x values here. So -3, 0, 3, and 5. All right, got 4 different ones there. Okay, now my y values be the range, which is -1, 0, 1, and then 0 is repeated again there, so I don't need to write it down again in there. It already shows up here. So I'll just have -1, 0, and 1. And then it asks, is it a function? Well, yes, it is. There is a repeated y value, but we don't care about that with functions. We just can't have a repeated x value. So I'm just going to write that here, yes, because we have no repeated x values. Okay, all of those x values are unique. So that means it is a function. Okay, so here is a function and we're trying to evaluate this, which means if we're trying to find f of 3, I'm taking 3 and I'm putting it into the function where I see my x's. Right? So when I do that, I've got -2 parenthesis, in place of that x I'm going to put 3 squared plus 3 times 3 and then minus 5. Okay, and I realize your calculators will do, most of this for you, but please write it out for me like this so I can see what you did, what you plugged in, and then you can just put it into your calculator from there. That's fine with me, but at least write out that one step so I can see what you are doing, what you're putting into the calculator. And so when you do that, you should get -14. Okay, and then on the other one, now we're going to put -2 in place of the x. So I've got -2 right there, parenthesis, -2 in place of the x squared plus 3 times place of the x, -2, and then minus 5. All right, and be careful with this. If you need to work this out by hand because your calculator won't let you put all of this in, be careful right here because you've got to do this exponents first. Right, so I'm going to work this one out by hand just to make sure everybody's with me. So we're doing negative 2 squared. Negative 2 times negative 2 is 4, and then I need to times that by a negative 2. All right, and then the rest of this is the same. Now let's do our multiply part. So negative 2 times 4 is negative 8. 3 times negative 2 is negative 6. And then minus 5. So I've got negative 14 minus 5 gives me negative 19 for our answer there. Okay, so just be really careful on that if you have to work it all out by hand. But like I said, as long as you write down that, first step so I can see what you put into your calculator, I'm fine with that. Okay, so we need to graph this. It's not telling us how to graph it, and so you could either make a table of values, pick some x's, figure out what y is, or you can take and put this into slope-intercept form, which means we need to get y by itself. So that's the way I usually like to do it. Or you can find your x and y intercepts. All right, and you could do it that way as well. All right, so there's a lot of different ways that you can graph it, and it doesn't matter which way you choose. Whatever is going to work best for you. If you're doing the x and y intercepts, remember if we do let y equal 0 and solve for x, that's my x-intercept, and if I let x equal 0 and solve for y, that gives me my y-intercept. Okay, so I could do that, and then or I could pick other points as well to see what it looks like. But if we change this into slope-intercept form, let's do that way as well. So I first need to start off by subtracting that 5x over because I'm trying to get y by itself. So I have negative 3y equals negative 5x plus 15, and then I just need to divide by negative 3. So then I get y equals 5/3 x, right? Negative divided by a negative is a positive, and then 15 divided by negative 3 is negative 5. Okay, so on this I could start by doing that, here's the y-intercept. So if you did this way, right, and you found if you put 0 in place of x and solved it, you would find that this is negative 5 on there. So I'm going to go down 5 places there on the y-axis, and then I need to do the slope from there. So it's rise over run, the 5 over 3. So up 5, and then right 3. So it would be there. And then just draw your line through both of those points. Right, make it as straight as you can. It's always so hard on here for me to do it. That looks horrible, but okay, let's see. I'll try. Oh no, I can't do it on this paper or in this thing very well. Alright, but you get the idea, right? Make sure you put your arrows on it and stuff too. Okay, so any way you want to solve or graph those is fine with me. Okay, so story problem. Manuel rides his bike for 4 hours and is 21 miles from his house. Okay. After riding 13 hours, he's 84 miles from his house. That is a long bike ride, 13 hours, wow. What is Manuel's average rate of change in miles per hour? Okay, so I'm kind of underlining some important parts of this. So when it's asking for rate of change, average rate of change like this, we're really finding the slope. Right? We need to find the slope, which means we need the slope formula, which is m equals y2 minus y1 over x2 minus x1. So we're going to be using that formula on here because we're really just trying to find the slope. Well, now we need to make these points, right? Because remember, these are, x1, y1 is a point, x2, y2 is another point. So these are where we're going to be making our ordered pairs. So 24 hours, 4 hours, he goes 21 miles, so I'm going to have 4 comma 21, and then 13 hours, it's 84 miles, so I have 13 comma 84. And notice that I have my hours first and my miles second, right? And that's good because notice it says, okay, we need it in miles per hour. So we need our answer in miles per hour. And so if we use this slope formula there and we subtract our y, so remember this is going to be, put it in a different color here, x1, y1, and x2, y2. All right, put it into that formula and I get 84 minus 21, right, so I'm subtracting the y's, divided by 13 minus 4. All right, so when I do that, I get 84 minus 21 gives me 63, and then 13 minus 4 gives me 9, and 36 divided by 9 gives me 7. So it's 7 miles per hour is the average rate of change. Okay. So you just need to make those into ordered pairs, into points, and then use the slope formula. Okay, so now we're going to be graphing something else, but this time we have an inequality, which means we need to do some shading. And also we need to look to see if we need a dotted line or a solid line. So remember, if we have a greater than or less than symbol that doesn't have the equal to part, it is going to be a dotted line that we're going to be using on here, not a solid. All right, but this is already in slope-intercept form. So remember, you can start with the y-intercept, so that would be down here at -2, and then my slope is -3 over 2. Now remember, that negative needs to go with the top or the bottom, not both of them. So I'm going to choose to put it with the top. All right, so from here, I'm going to go down 3 places, and then to the right 2, because my 2 is positive. All right, or I could have went up 3 places, 1, 2, 3, and then to the left 2. And you can see those still end up in the same line here, which should look something kind of like this. Okay. Oops, but what did I do? I did that wrong, right? Remember, we had to have a dotted line there. So let me try and write this in as a dotted line. Okay, and now I need to do some shading of it. So either my solutions are going to be above that line or below the line. And so I'm saying that y is greater than that line I just drew. And the stuff greater than it is the stuff above that line. So all of the stuff here would be my shaded part. Okay. And then that would be done. That would be your answer, just this part. Okay, so watch those inequality symbols. Make sure you use a dotted line if you need to, solid line if it has the equal to part. All right, so now we got find an equation of a line that passes through these 2 points. And so when we're trying to find an equation of a line, right, we need to know what the slope is, and we also need to have the y-intercept as well. But let's start here. So we know that we need to use that slope formula again like we used before. So y2 minus y1 over x2 minus x1. All right, so here's my x1, y1, and my x2, x2, y2. All right, so if I put that in there, I get -3 minus a -2. Be really careful when you're minusing a negative. All right, and then I've got on the bottom 10 minus 5. So on the top, right, I really have minusing a negative is really adding. So -3 plus 2 is -1, and 10 minus 5 is 5. So my slope is -1/5. All right, so now I need to use another formula. Make sure you have this one memorized too, the point slope formula, which is put this color, y minus y1 equals m times x minus x1. So if it's ever asking you to write an equation of a line, this is the formula to use for it. So let's put in what we know, right? And let's just look at this one. I already have that labeled as x1, y1, and I need to put the x1, y1 into this equation, so let's do that. I don't know what y is, right? So I'm going to keep that as y. I need that in there, minus my y1, which is -2, so minus a -2, equals m. Well, I just found that to be -1/5, so -1/5 goes there, times x minus x1, which is 5. Okay. All right, now I just need to get this into that y equals mx plus b form. So let's start by, well, subtracting a negative is really adding. So I get y plus 2 equals, and then here I need to distribute those through. -1/5 times x is -1/5 x, and -1/5 times -5 is going to be a +1. But if you need to do some work out to the side to, to do that, -1/5 times -5/1, all right, then you can see, all right, I'm going to end up with 5. -1 times -5 is +5 over 5 times 1 is 5, all right, and 5 divided by 5 gives us 1, so that's how I got this +1 there. All right, and then the last step is we got to get y by itself, so let's subtract the 2 over. So I get y equals -1/5 x, and then it's going to be 1 minus 2 is -1. And that would be your answer. That is the line that goes through those 2 points. Okay. Alrighty. And remember, if you need to, you can always rewind this, go back and look at it again if you need a little bit more time on it. Okay, so this one is telling us to use the substitution method to solve it. Personally, I mean, it's telling you the easiest way to go about this, but if you chose to do the elimination method on this instead, I would still give you the points on it. It doesn't really matter to me which method you use, so whatever works best for you. But to use the substitution method, notice on the second equation I have x equals all of this stuff. All right, so that's what x is. Well, then I need to take all of that stuff and put it in our top equation in place of x. All right, so when I do that, I have 3 parentheses, place the x, I'm going to put -5y minus 2, and then continue out, writing out the rest of that first equation, so minus 2y equals 11. All right, so here to solve for y, let's go ahead and distribute that through. Get -15y minus 6 minus 2y equals 11. Let's get our like terms together. -17y minus 6 equals 11. Let's add our 6 over. At -17y equals 17. So that means y equals -1, because I'm going to divide by -17. All right, but remember, I'm not done yet. All right, it's asking us to write it as an ordered pair. So I'm going to go ahead and just write my ordered pair up here next to it so I remember to do that. So I know my y is -1. Now I need to go find x. Well, the easiest way to do that is to take this -1 that I found y is and put it here in place of our y. So we get x equals -5 times -1 that we just found there, and then minus 2. So x equals, that multiplied together is +5 minus 2, which gives me 3. So x equals 3. So I'd have 3 comma -1, and that is my answer. And remember, when we're finding these, this is telling me the point in which those two lines intersect each other, right? So if I've got, 2 lines or something like this, that's the point that they're intersecting. Okay, keep that in mind. That's what we're finding when we're solving these systems of equations. Okay, keep going here. All right, so now this one's saying use the elimination method. So let's look at one like this. So in order to eliminate, it's also called the addition method because I need to eliminate them in such a way that, like, when I add them together, those will eliminate. Well, if I do that right now, if I, just add them together how they are, 3x plus 4x is 7x, and 2y minus 3y is negative y. So neither of those zero out with the way they are. So I need to multiply one or both equations by something. So I'm going to choose to get rid of my y's. You could get rid of your x's first, but I'm going to choose y's just because I have a positive value and a negative value. And I need that in order for us to zero these out. And so I'll take this top equation and I'm going to multiply it by 3 because 3 times 2y is 6y. And then I'll take that bottom equation and I'll multiply it by 2. All right, 2 times negative 3y is negative 6y. So let me go ahead and just distribute those through and show you what we have here. So 3 times 3x is 9x. Distribute that through, we get plus 6y. And then 3 times negative 13 is negative 39. Then let's distribute the 2 through. So 2 times 4x is 8x. 2 times negative 3y is negative 6y. And then 2 times negative 6 is negative 12. And so you can see when I do this, those y's eliminated, right? We were trying to make that happen, and we did, right? Those y's are gone, and so now I just have x's left to solve for. So when I continue on here, 9x plus 8x gives me 17x. And then if I combine these together, negative 39 minus 12 is going to give me, 51, negative 51. And then I just need to divide by 17. Negative 51 divided by 17 is going to give me negative 3. Okay. So again, I need to write my answer as an ordered pair. So I found that x is negative 3. Now I need to go figure out what y is. So I'm going to use this negative 3 and put it in place, and I can put it into either equation. So it's just like which one looks easiest. These look about the same, so I'm just going to choose to put it into this bottom equation here. All right, so I've got 4 times x, which I found to be negative 3, minus 3y, I don't know what y is, I'm trying to solve for it, equals negative 6. Alright, so multiply those, I get negative 12 minus 3y equals negative 6. Let's add the 12 over. So that'll give me negative 3y equals positive 6. And then all that's left to do is divide by negative 3. And 6 divided by negative 3 gives me negative 2. So y is negative 2. And that would be my answer. That is the point in which those two lines are intersecting each other. Alright, another story problem here. Right, these mixture problems show up a lot of times on the exam, so let's work through this one. How many pounds of chocolate costing $8 per pound should be mixed with trail mix costing $5 per pound to create a 50-pound mixture worth $6.80 per pound? So this is, we need to solve using systems. So we need to write two equations. My first equation is going to be just about pounds, right? What we know about the pounds. Well, all we know is that we need it to add up to be 50 pounds. All right, so I don't know how much chocolate, I don't know how much trail mix, how many pounds of each, but I know together they need to be 50. All right, well, let's make sure that we're assigning some variables. I'm going to call my chocolate C. Let's do that in the purple color. And then I'm going to call my trail mix T. All right. So when I do that, I'm going to have don't know how much chocolate, so C plus however much trail mix we need equals 50. Alright, because all I know is it needs to have a 50-pound mixture. Alright, and then my second equation is where I need to put the cost of stuff in. So it's like we got to do the price instead on this one. Okay, so let's kind of write it down here. So the price. So with the price, well, I know that the chocolate costs $8 per pound. So I'm going to do 8 times the C, because I don't know how many pounds of chocolate I need, but each one is going to cost $8. Alright, and then plus the trail mix costs $5 a pound, so 5 times T, and then equals 50. Alright, and now I can use the substitution or elimination method to try and to figure this out. Okay, I'm going to choose to use the elimination method, but you could do it either way. Okay, so if I do this and say that I'm trying to let's get rid of our t's here. Well, in order to do that, I'd need to multiply the top equation by a -5. Alright, let's see. Alright, that one is too big. Sorry, that was just not looking very good. Alright, so multiply that by a -5. And so when I do that and distribute that through, I'm going to bring it down here. So -5c plus, minus 5t, and then -5 times -50 is -250. And now you can see, alright, well, we got rid of those t's, which is what we were trying to do. And then when I add this the rest of the way, alright, 8c minus 5c is 3c, and then 50 minus 250 is going to give me, oh wait a minute, I did something wrong here. I'm so sorry. Notice that I didn't even use the $6.80 yet, right? I meant to put that next to here. I'm doing 50 times $6.80. And so 50 times 6.8 gives me 340. Okay, so when I multiply those together, I get 340. And so over here, 340 minus that 250, all right, let's see, is going to give us 90, and then I just need to divide both sides by 3. So C equals 30. And so that's the chocolate, right? So make sure we put that here, is 30 pounds. And I know altogether I need 50 pounds, right? So really I'm trying to think 30 plus what gives me 50? Well, that would be 20. Or I could just do 50 minus 30 gives me the 20. All right, so 30 pounds of chocolate, 20 pounds of trail mix on that. All right, now we got properties of exponents we're dealing with here. And so it's all the way simplified when there's no negative exponents left, no parentheses, and all of our x's are together and our y's are together. Excuse me. Okay, so there's a couple of different ways you could do this, and so if you thought about doing it a different way than I do, it's okay. It still could be correct, right? What I like to do is get rid of, I don't like distributing these negative exponents because then that just creates a lot of negatives, and I know with more negatives seems to be more mistakes. So what I like to do is I can see both of these are negative, and so I'm going to choose to flip this. So I'm going to take all of the stuff that's inside here and it's going to go in the denominator, right? So that 3, and notice that exactly how it is here, x to the -1, y to the 5th, right? and then instead of being to the negative 2 power, now it's to the positive 2 power, because that's what I was doing by flipping it. And similarly, right, now I'll take what's on the bottom here and put it on top. So I've got x to the 4th, y to the 3rd, still raised to the 2nd power. Okay, so I changed it from a negative to a positive. All right, so now I've got those positives, so we can go ahead and distribute that power through. When we have a power raised to a power, we're multiplying those. So here I get x to the 8th power, y to the 6th, over, now make sure you give this power of 2 to this, right? So it's 3 squared, which is 9, and then x to the negative 1 squared is x to the negative 2, and then y to the 5th squared would be y to the 10th. Alright, now I can see I have a negative exponent and I can't have that in order to have it simplified, so let's go ahead and get this and say, okay, yeah, that guy wants to go upstairs, right? So I got x squared upstairs now, it's no longer down there. And so now I can combine my like terms together. So I've got this 8x, let's see, let me do a different color here, 8x and x squared. All right, so this time these are connected by multiplication, so that means I add those exponents together. So I've got x to the 10th over, I've got 9, and then I've got my y's that I also need to combine together. All right, you could do those in separate steps if you wanted to, but I'm just going to do this together here. So when I'm looking at my y's, I see, all right, there's more y's on the bottom than there are on the top. How many more? Well, there's 4 more. All right, so I'm subtracting these, but I know that they're going to end up on the bottom because there's 10 of them down here and only 6 upstairs. Okay, and then right there, that is my answer. I have it all simplified. There's no parentheses, there's no negative exponents. I've got my x's together and my y's together. So that would be my final answer. Okay. All right, scientific notation. We're multiplying these together, right? It's parentheses right next to each other, so that means multiply. So we'll start by just multiplying those decimal parts together. So 5.3 times 1.7, put that in the calculator, you get 9.01. And now I need to multiply these other parts, right? So 10 to the negative 20 times 10 to the 39th. Well, again, it's connected by multiply, and so that means that we need to add those exponents together. So negative 20 plus 39 is going to give me positive 19. So I've got times x to the negative 20 plus 39 is positive 19. Right, and it wants it in scientific notation, and we have it that way, so that would be my answer. All right, now remember, scientific notation, this number here out in front has to be between 0 and 10. So if it was a number bigger than 10, we'd have to move it, move the decimal point, and if it was smaller than 10, we'd also have to move it. But this one was a number already between 1 and 10, so we don't have to change anything on that exponent of 19. Okay, for number 20, this one, the subtraction, the thing that I see happen most often on this is people forget that negative is kind of like a negative 1 that's being distributed to this, right? We're changing the signs of all of these. So we really have plus 8x to the 5th. Negative 1 times 5 is negative 5x squared, and negative 1 times 4 is negative 4. All right, and then now I can add those together with what I have here. I'm going to just put all of this stuff underneath here. So I've got negative 3x to the 5th minus 9x squared minus 2x, and notice that there's no x to line up with it, so I've got to be careful about that. And that's why I like to line them up like this so I can make sure I'm adding like terms together. So here, when I combine those together, I get 5x to the 5th. Combine these together, I get negative 14x squared. And I like to keep it in descending order, so I'm going to write that negative 2x down and then the minus 4. It's not wrong if you put it in a different order. It's just like we usually like to have it in that descending order. It's just easier to keep track of our terms. And so that would be our answer. All right, on 21, we're foiling, right? I mean, we're distributing, but we talked about that acronym FOIL in order to do this. So that means we're going to multiply the first numbers together. So 3x times 4x is 12x squared. Then that O stands for outside. So if I multiply the outsides together, 3x times 2 is positive 6x. Then I need to do the I, which is the inside. So negative 3 times 4x is going to give me negative 12x. And then the last thing, the L is last, so negative 3 times, oops, let me get a different color there, negative 3 times 2 is going to give me negative 6. All right, and then I just need to combine like terms together on this to get my answer, and those are like terms, so I've got 12x squared. 6 minus 12 is negative 6x, and then minus 6. And that would be my simplified answer. Okay, so multiply it, do the FOIL, and then combine like terms. Okay, hopefully we can get this. We got 8 more problems to go here, so we'll get through these. And notice that some of these take a little bit longer than others, but some, are going to be less time consuming too. So just make sure that on the exam when you're going through it, don't spend too much time on one problem in particular. If you're getting really stuck, just skip it, go on to something else, because usually something later in the test might, jog your memory to be like, oh yeah, I think I remember what to do now. Okay, but make sure you get through all of the questions, because these aren't in order from like easiest to hardest. So get all of those questions that you for sure know how to do, and then you can spend more time on those questions that you're like, ooh, I wasn't quite sure if I was doing this. Okay, so here we need to factor. When we're factoring, first thing we always want to look for is the greatest common factor. Well, we can see on this that each of these have a y, so the greatest common factor here is y. So I'm going to divide a y out of each of these parts, right, which will leave me y squared plus 3y and then minus 40. And then I want to look and see if it will factor further on this. So what multiplies to be negative 40 that adds to be 3? Well, I know 8 times 5 is 40, all right, but to get a negative 40, that means one of these would have to be negative. And to end up with a positive 3, when I'm adding them together, I'd need to do 8 plus a negative 5, right? So the negative is going with the 5 on that one. So when I write this out, all right, I've got y times y is my y squared. What times what is negative 40 that adds to be 3? Well, I got a positive 8 and a negative 5. And that's all we can do to factor it, so that is the answer. Alright, so here's another factoring one, and notice this time, like, my leading coefficient isn't a 1 like I had up here, right? So I could just, do this a little different. So I've got to make sure that I'm incorporating that 8 into it. So the way I do that is I have to do 8 times negative 3. So this time I'm thinking what multiplies to be negative 24, right? Not just negative 3. I'm going to multiply those two together. That adds to be negative 10. All right, so if I list out the possibilities here, I got 1 times 24, 2 times 12, 3 times 8, 4 times 6, x. All right, and in looking at these, some people are like, well, wait a minute, wouldn't both of these work to get us a negative 10? And only one will. So let's look at this and see. So it needs to multiply to be a negative 24. So that means one of the numbers need to be negative, not both of them. So if I made one of these 4 or 6 negative and I put it together, I would not end up with a negative 10. All right, so that means it has to be this one, this 2 and 12. And in order to end up with a negative 10, my 12 needs to be the negative number. Okay, now I can't just put these into the parentheses like I did before. I need to make this into a 4-term polynomial is what most students are doing, or doing the box method or something. So I'm going to keep that first term the same, 8x squared, but my negative 10x I'm splitting up to be 2x and negative 12x. Right? It doesn't matter which one I put where. I could put negative 12x here and 2x here, but just make sure that you keep that negative with the 12, the positive with the 2. And then that negative 3 comes down also. And then from here, I can just do some factor by grouping. So I'll split this in half, and then I can see, all right, what is the greatest common factor between those two terms? Well, it looks like 4 will go into both 8 and 12, and then there's also an x that can come out. All right, so 4x can come out of that, and then that's going to leave me with 2x minus 3. All right, now on this one, look at how this is already 2x minus 3. So be careful on this, because sometimes people are not quite sure what to do with it. So I have to think, what's my greatest common factor here? Well, there is only 1 is the only thing that I can do. So I need to write it as 1 times 2x minus 3. And I do it that way just to make sure that I can see that, all right, these guys, all right, are my greatest common factor now, so they go in one parenthesis, and then these are my leftovers that go in the other parenthesis. Okay? And so that would be my answer. And to check it, I could just FOIL that back together and see if I end up with what I started with there. And if I do, then I know I did my factoring right. Okay, this number 24, there was so many people on the last exam that missed this as a difference of squares. So be really careful on this. Make sure that you see there's a couple of different ways that you can think of this, right? Notice that 16 is a perfect square and 81 is a perfect square. So and one way that you can do this, right, if you see that both of those are perfect squares, is I can think to myself, okay, what times what is 16, right? That's the same number. Well, that would be 4x and 4x. Right, 4x times 4x gives me that 16x squared. And then what times what is 81? Well, that would be 9 and 9, but I need there to be no middle term left. So that means one of these needs to be positive and one needs to be negative. Okay, so that is my answer. All right, and so it's actually pretty simple, as long as you remember kind of how to go about it. But I want to just look over here. I just want to check this, show you, like if we checked this, all right, and I multiplied these back together, right, what happens? Why one needs to be positive, one needs to be negative. Okay, when I multiply those, I get 16x squared. Multiply those, I get negative 36x. Here I get positive 36x, and then 9 times negative 9 is negative 81. So do you see those middle two terms zero out? Negative 36x plus 36x is gone, and I'm just left with that 16x squared minus 81, which is what I started with. So I definitely have this factored correctly, so I can check that way. All right. Number 25, all right, we're getting there. So this time it says to solve. Well, we're going to use factoring to solve it. So this was another one on the last exam that a lot of people missed. All right, so make sure everything is over on one side. of the equation. You got to get everything over there first, and then you're going to factor it. Since the leading coefficient's 1, I can just, ask myself what multiplies to be negative 18 that adds to be negative 3. All right, so I've got x and x here, so 6 and 3, right? 6 times 3 is 18, but in order to be negative, one of them needs to be negative, and it needs to be the bigger number because I end up with negative 3x there in the middle. So negative 6 and positive 3. All right, and notice it's equal to 0, so I need to keep that equal to 0, and I'm not done there, right? That's the factoring of it, but I haven't solved it yet. So now I need to take each of these parts, put them equal to 0 to solve it. So here, when I add the 6 over, I get x equals 6. Subtract the 3 over, I get x equals negative 3. All right, and those two are my solutions. Those are my answers. Okay, number 26. This is another one kind of on the exam that I noticed was missed a lot. So I'm pointing that out just so you guys can make sure that you go back over some of these. You did. So when you're adding radicals together, they have to have the same number inside the radical as well. All right, we can't add these together the way they are. If it was multiplication, we could do it, but with adding or subtracting, we got to get those to be the same. So the easiest way to go about doing that is to start off maybe just doing the prime factorization of 32 and the prime factorization of 50, all right, to help us figure out what gets to come out of the square root and what has to stay inside. So 32 can break down to be 4 times 8. 4 is just 2 times 2, and 8 is 2 times 2 times 2. So that's really 2 to the 5th power, right, is what I get there. Now 50 can break down to be 5 times 10, and 10 breaks down to be 5 times 2. All right. So if I'm looking at this, so looking at the 32 part, all right, remember things have to, since it's a square root, things have to come out in groups of 2. So this gets to come out as a 2. Let's see, I'm just going to get rid of, oopsie, what happened there? Let's see here. So that 2, those pairs of 2 get to come out. Let's see what's going on here. No, and then this gets to come out as another 2, right? And so I already have a negative 2 on the outside, so I had negative 2, and when these guys come out, they're going to multiply by that negative 2 that's already out there. And then stuck inside, I still have another 2, right? So I've got negative 2 times 2 times 2, which is negative 8 square root of 2. All right, now let's do that 7 times square root of 50. So here I can see a 5 gets to come out, and when that comes out, it multiplies by that 7 that's already out there, and then left inside is that 2. All right, so if I simplify this up, 5 times 7 is 35, and then square root of 2. Now I have both of those radicals exactly the same, right? Got the same stuff inside, so now I can actually add those together. So negative 8 plus 35 is 27, and then both of those are square root of 2, and I keep it as square root of 2 in the answer. So 27 square root of 2 is my answer. Okay, here's another multiply question that is like a FOIL again, like we did before, but now it has some radicals in it. So on this one, you got to keep track of your radical rules with addition and subtraction and keep those straight with the multiplication. Okay, so let's go ahead and do this. So negative 5, so I'm doing first outside, inside, last, right? So I'm multiplying negative 5 by 2 is negative 10. Then negative 5 times negative square root of 3 is going to be negative times a negative is a positive, so plus 5 square root of 3, right? I can't multiply those together. I can't make that a 15 because this negative 5 is not inside a square root. It's on the outside. All right, let's keep going. So here, square root of 3 times 2 is plus 2 square root of 3. And then the last thing we have here, square root of 3 times negative square root of 3 is negative, and then square root 9. All right. Okay, well, let's combine together what we can here. So square root of 9 is just 3. So I'm just going to make this as a minus 3, right? Just to simplify that more. I can combine these guys together because, again, we have what's inside the same, right? Those are both square root of 3. So add the outsides together. It will be 7 square root of 3. And then I still have that negative 10. So now I can combine my negative 10 with my negative 3, which will give me negative 13, plus, there's nothing else to add with that, so I'll leave it as 7 square root 3. So negative 13 plus 7 square root of 3 would be my answer. All right, so when I'm multiplying, remember, I don't have to have the same thing inside the radical like I did, but with adding them, I have to have those be the same. Okay. Okay, we're getting there. So now we're solving this radical equation. So you've got to start this by getting getting that square root part by itself. All right, and so that means I need to start by adding the 3 over. So when I do that, I get square root of x minus 14 equals 2 plus 3 is 5. Now I ask myself, how can I undo? I'm trying to solve for x, but x is kind of trapped inside the square root. So how can I undo that square root to get it out? Well, to undo square roots, we square. So I'm going to square this side of the equation, which means I need to square this side. All right, so that square root and that square undo each other, which just leaves the x minus 14 on that side. And then I have 5 squared is 25. And now to get x by itself, I just need to add that 14 over. And so x equals 25 plus 14 is going to give us 39. Okay, and again, you can check your answers on this by putting 39 back in place of x here. So any questions that say solve, you can always go back and check those. Okay. All right, 2 more questions here. So number 29, we got on here, it's not telling you that we're using the Pythagorean theorem, but whenever we are dealing with a right triangle, right, and trying to find the length of a side, and we want to use that Pythagorean theorem. So make sure you have that memorized. A squared plus b squared equals c squared. All right, and remember with this, like I said, it has to be a right triangle. Oh my goodness, it's so hard to draw a straight line on this. All right, so here's my right triangle. And then C always has to be that hypotenuse, that longest side. And then A and B can be either of these 2 legs. It doesn't matter which one I call which, right? But I need an A and a B. That B looks like a 6, so I'm trying to change that to make it look better. Okay, so when I'm setting this up, let's think about what we have here. So it gives us a hint to draw a picture, which is always a good thing to do if you're trying to imagine something here. All right, so here is my wall. Okay. So it says an 11-foot ladder is placed up against a building. All right, and so this is my ladder. Oh, it looks kind of weird, but kind of go like this. All right, here's my ladder, and it's being placed up above that building. So this is 11 on this side. If the base of the ladder is 4 feet away from the building, so that would be this part, all right, from the base to the to the ladder, the base of the ladder to that building, 4 feet away, then it wants to know how high up is it reaching on there. And so that's what I'm trying to find is x. So when I put this into the Pythagorean theorem, I'm going to have x squared plus 4 squared. All right, and then that 11 has to be on the other side. All right, that 11 squared. Okay, and notice it says to round your answer to 1 decimal place. Make sure you watch that on your test. So 4 squared is 16, 11 squared is 21, or sorry, 121. And then I need to subtract the 16 over. So that gives me x squared equals 105. And then to undo that square, because I just want x by itself, not x squared, then I need to square root both sides. All right, so when I do that, those x's undo each other, leaving x there. And then I can just put that into my calculator to figure out what that is. So when I do that, square root of 105, and I round it to the nearest tenth, that's going to be 10.2. All right, so 10.2 feet is how high up it would reach. And remember that hypotenuse always has to be the longest side. So if you got an answer here that was bigger than 11, then you did something wrong, probably in where you put the numbers and stuff. So watch that closely. Okay. All right, and the last one, another little story problem here. A boat can travel 48 miles downstream in 4 hours while it takes 8 hours to make that same trip upstream. Find the speed of the boat and in still water and the speed of the current. Okay, so these are the two things that I'm trying to find. So those are my variables. So I'm going to say the speed of the boat, I'm going to call B, and the speed of the current, I'm going to call C. All right, just to kind of keep that straight. When I'm setting up little, chart, if you want to set it up that way, we're dealing with, upstream and downstream. So I'm going to put down and up. And then I'm given things about distance, rate, and time. So I'm going to have distance, rate, and time. And then I need to fill in what I know here about each of those. All right, well, it tells me that the distance is 48 miles. So you're going down and then you're going back. So you're still doing 48 miles both ways. So I'm going to put 48 on both of those. All right, now it tells me that downstream it takes me only 4 hours. Right, so downstream at the time is 4 hours, where it's going to take 8 hours going upstream. All right, and then the rate is what I'm trying to find here, and the rate is made up of these two things, and this is probably where I see a lot of the mistakes on this. Remember that rate, in this sense, when we're dealing with like a current, of a river, or if we're dealing with the plane, if there's like a wind speed, then we got to take those things into account. So the rate is the boat speed plus or minus, right, depending on whether it's going downstream or upstream, plus or minus the speed of the current. So the boat speed has to go first, then this current speed second. So it's going downstream. That means it's pushing it faster, so that's got to be the plus. So I've got B plus C. And then upstream, it's going, against the current, so it's slowing it down, so that's B minus C. All right, so now I have two equations here. So I'm going to write those out over here. So I've got, first one, remember it's distance equals rate times time. All right, so I'm going to have 48 equals 4 times B plus C. And then my other one is 48 equals 8 times B minus C. All right, and I just put those numbers, I can switch, the order of those if I needed to, because it's multiplication, and 3 times 2 is the same thing as 2 times 3, right? So I can switch that around. It just makes better sense to my brain to write it that way. Okay. And then you can do this one of two ways from here. You could distribute the 4 through, distribute the 8 through, and then try and like eliminate one of the variables. But what's going to be faster on this is think about how this is connected. 4 is connected to this by multiplication. So I can undo that multiplying by 4 by dividing both sides by 4. All right, so here that 4 divided by 4, those are gone. And then I'm left with 48 divided by 4 is 12 equals b plus c. All right, let's do the same thing over here. All right, it's connected by multiply, so if I divide both sides by 8, all right, then on this one, I get 48 divided by 8 gives me 6. So I got, 6 equals b minus c. Minus kind of looks like a multiply, but that's a subtract. Okay? And now I can just put these together to do, and I'm going to do the elimination method, because look at how easy that becomes when I do this. When I add these together just the way they are, those c's, eliminate themselves. Right? So those c's are gone, and I'm just left with b's to find. So 12 plus 6 is 18, and then b plus b is 2b. And divide by 2, we get b equals 9. All right, and so this is my boat speed. All right, so 9 what? Well, it was talking about miles, all right, per hour. So mph, miles per hour. Make sure you remember those labels. Okay, and then I need to find out the speed of the current. Well, I can just, think about when I'm, doing this. I kind of like this one the best to look at. All right, so if I'm putting 9 in place of my b here, all right, I have 12 equals 9 plus c, and so if I just subtract 9 over, that's going to give me the speed of the current, which is 3. So 3 miles per hour is the speed of the current. And make sure the speed of the current, like if you're kind of checking to make sure your answer makes sense, this current should be less than the boat speed. Because think about it, if your current was stronger than how fast your boat was going, you would not be moving forward. It would be pushing you backwards. So it's got to be less than there. Okay. All right, so hopefully that helped to go through some of these together, and see me working them out. Like I said earlier, I will post I'll send it to you in a message in your Canvas inbox, okay, so that you can have both the answer key as well as just the question, so you can maybe start working through those as well if you want, okay? All right, if you have any questions, please reach out to me. Let me know. I'm here to help you. Make sure you get that test scheduled today, right? If you haven't got it scheduled already, get it scheduled. I don't want you to run out of time. You cannot take this exam late. It has to be taken during finals week, okay? So I hope you guys have a wonderful rest of your day, and reach out to me if you need help. Thanks.